Hello, everyone, and a wonderful day. Yeah, so there's Benjamin.
Hello.
So, welcome to our webinar Radioline for Beginners. So, today we want to explain you something about the very nice Radioline wireless system and what's behind this. But first, a short words how we work here in this webinar. So, as you can see, all your microphones are muted. Please use the chat if you have questions. At the end of the training, we will open the mics and then you have also the chance to talk directly to us. So my name is Jörg Brothers. I'm working as communication interfaces. I'm a general contact for industrial communication stuff. Together with Benjamin Fiener, the product manager for the Radioline, Nearfi, and other things, we do the training. And of course, we have Felix Lehmann. He's the man in the chat. So if you have the question, Felix will directly answer them. And as I mentioned it before, so we will answer all questions latest at the end of this session. So, yeah, I think we can start. So the training is recorded. And yeah, as I mentioned, Radioline, one system, endless options. So yeah, Radioline, I know many years ago, we developed this Radioline system. We have also a lot of experience at Phoenix Contact for industrial wireless. When I started more than 17 years ago, I started directly as a product manager for wireless. Since 2002, we had a very old Redline system that was more or less a beginning. And then we have also wireless LAN devices, Bluetooth devices in the network technology group. And since 2011, we have the Radioline system in the market, and it's very successful. Yeah, so when when we look on our portfolio for industrial wireless, so we have different license-free wireless stuff in our portfolio. As you can see here on the left-hand side, we have the newest technology is Nearfi. It's for near-field communication. So if you want to transmit wireless data and energy, in this case, over a few centimeters, then the best choice. Then they have more or less a medium range. We have very nice wireless LAN devices, Bluetooth multiplexer, or the Bluetooth EPA devices. Here we talk about distances of a few hundred meters. And then we call it long range. Here we have, as you can see on the right-hand side, the mobile devices for LTE 5G. So that is a bit different to the other wireless technologies. And here you can find also the trusted wireless Radioline. So with the Radioline system, that's a device where you can transmit data over longer distances, over a few kilometers. And this will be the topic for today. And we will explain you something about that. But in general, what is Radioline? But first, I just want to know your experience. So therefore, I've prepared a survey, and please answer the questions. So hopefully it works. So now you see on your screen the questionnaire. Do you already have experience with a Radioline wireless system? 1 stands for no, I have no experience. And 5, you're an absolutely expert. So please make your choice. It will be nice if you can answer the questions. Yep. On the right-hand side or on the tab survey in Teams, you can also see the answers. Yeah, so as I can see, 23% have no idea, 20% a 2, and 37% 3. And we have also an absolutely expert Okay, thank you. So as I can see, I think some of you never heard about this stuff, and that's why we are doing this webinar. So wireless systems for I/O and serial data, that stands for Radioline. So at the end, when we talk about wireless all the time, as you have at home, you talk about wireless LAN or Bluetooth. So in this case, our technology for Radioline is trusted wireless. So it's a proper proprietary technology. It's developed by Phoenix Contact, so it's our own technology. And this technology is special because it fulfills the requirements for industrial uses, so especially for the infrastructure, long distances with small IOs or serial data we can transmit here over a few kilometers. The physics it's behind, so our guess was also that we can transmit very high data rate, but it's not directly possible. Therefore, we focused here on IO signals, analog and digital, or serial data, RS485, and so on. The system is very easy with a startup, some wheels, and we can fulfill therefore a lot of application. But first, I just have a short video for you.
Radioline from Phoenix Contact. Wireless transmission of your I/O signals into your system with only one turn. The special features: easy startup of wireless networks thanks to I/O mapping. Assignment of inputs and outputs takes place easily via a thumbwheel directly on the module, completely without programming. Radioline is suitable for various different application cases, from the simple point-to-point connection up to complex networks, and transmits serial data as well as analog and digital signals with the latest trusted wireless technology. Reliable wireless transmission with Radioline from Phoenix Contact.
So that was a short introduction. Of course, when we talk about the distances, I talk about free line of sight. So in best cases, we can cover a few kilometers depending on the radius. If there are some hills, some building in between, so of course that reduces the distances, or sometimes it's also not possible in this case. But it's also at the end the physics. So a typical application for Radioline are the water treatment plants. So that's very popular since many, many years. Pumping station, they're remotely far away from the control room, and rotating parts, filling level monitoring. On the other hand, we have also a application in the traffic engineering, the displays, signal boards, and so on. And the process industry, as you can see later, we have also X approvals on the devices, therefore for tank fill level monitoring, temperature monitoring, pipeline monitoring, leakage monitoring, and so on and so on. Oh. Okay, yeah. But later we will explain you a bit more about other applications, and we want to jump a bit deeper into that. On the power engineering, material handling, in wind farms, we have application power stations and monitoring of motors and conveyor belts. So that's also something we have done in the past. So only a few words to the technology. Trusted wireless is specially developed for the industrial use, as I mentioned. But here also important, the question we will get very often also from our customer, is it safe, is it secure? Of course. On one hand, it's proprietary, so nobody knows what kind of protocol we are using it, where is the positioning of the data, and so on. But we have also an AES encryption on Telegram, and we have an integrated checking inside the system. So we check the data if they are right or wrong. On the other hand, we have big distances, so adjustable data rates and a high receiver sensitivity. So therefore we can cover a long distances. And depending on the system, we have a frequency hopping and a wireless LAN blacklisting. So a very good coexistency. But what's behind this? So here I've also a short video about the technology.
You're on the go and you're talking on your mobile phone. All of a sudden, the connection starts to break up and then it's gone. Everybody has experienced this, unreliable wireless connections. And sometimes you also might wonder just how secure your conversation is from prying ears. Such situations have to be avoided in industry, and many companies hesitate to switch to wireless for long distances exactly for this reason. That's why Phoenix Contact developed the trusted wireless technology. With no registration or user fees, trusted wireless is different. It guarantees security, availability, and long range. Look for yourself. The high level of security, for instance, is guaranteed by the non-publicly accessible protocol, the encrypting of the data, and the authentication. Authentication is that each data packet is assigned an individual number. The recipient needs to have this number in order to receive the data packet. That means no one can intercept or change the data. In addition, the signal does not stay on one frequency, but alternates frequency according to a uniquely encrypted pattern. This creates additional security and simultaneously ensures the availability of the signal if one frequency should become disrupted. The wireless connection heals itself, in a manner of speaking. In other words, trusted wireless is not only secure, it is also always available. It includes the ability to avoid occupied frequencies, such as the company's own wireless LAN. In this way, the signals can't mutually interfere. Trusted wireless guarantees security and accessibility over a distance of many kilometers. How does it work? With a variable data rate. It's like two ships at sea. The larger the distance between them, the slower the Morse code transmission. The shorter the distance, the faster the transmission. Trusted wireless is also a flexible and outage-safe mesh network. Assume the two ships are too far apart to reach each other. The solution? They use closer ships, other network members, as so-called repeaters. That's how the signal transmission works in a mesh network. High security and availability over a great distance. That makes Trusted Wireless by Phoenix Contact the wireless solution for extended industrial plants. Phoenix Contact, inspiring innovations.
This was a short introduction about the technology. As you can see, it's a very flexible system. And as I mentioned, one system for many options. So what kind of application we can fulfill? So in this case, we can have, we have four different kind of options directly. So I just want to explain it also a bit from the technical side. So the first one, we call it I/O to I/O. So that means the Radioline system just act as a cable replacement. So here on the left-hand side, you see a radio, that's a wireless module. Then you have an I/O card connected to it with a digital input or output and analog in and out. So here just as a multiplexer, digital in and on the other side digital out, or analog in, analog out. So that's what we call I/O to I/O. On the other hand, we can make it a bit more sufficient for the customers, that you do not need so many devices, but at the end, you can directly connect it to a controller. So in the field, you can also connect, you can install a Radioline system with a digital and analog input for a pump station, for example, and then you can transmit it only to the master radio. And this one is directly connected to Modbus RTU, so it's a serial protocol. So you can directly connect it to a PLC Next control or to other third-party controllers. So that's very efficient. Then the radio acts as a Modbus slave. On the other hand, we have the serial to serial. So that means we can replace a serial cable. So if the customers from us has a RS485 or RS232, so you want to build up only a wireless connection between two controllers, then it's possible also with Radioline. In this case, two examples, we can do it with Modbus. So Modbus RTU, it's possible And with some limitation, we can also do it with Profibus. But here, I will explain you later. And the fourth option is we have an I/O to Modbus RTU in parallel. So as you can see on top, so also I/Os in the field to the Modbus. The Modbus is directly connected to the controller here on the left-hand side, and also a separate Modbus end device like an EM Pro can be connected also to the radio and in parallel I/O data. So as you can see, it's very flexible, a bit complex, but very nice for the end users. Therefore, we can fulfill different applications. But now I want to jump in all these four options separately. The first option, I/O to I/O, as I mentioned, so here the left side, that's the Radioline head station, we call it, the Radioline. So this device has only an RS-485, but no I/O connected. But to build up a communication, so you have the thumb wheels on this device. So here the yellow one is for the Radioline connection. You must set up 1201, that's a master radio, and the other device must have a higher number, 02. Then they build up a communication automatically. And if you want to share I/Os, then you can connect here, for example, a digital input and a digital output module, set them at the white thumb wheel, set them to the same address number, so 67 on both sides, then they map each other. So very easy, only with the help of your fingers, you can establish a communication and share the data from one point to the other point. But it's also possible to have a multiple or signal multiplication, one input to several outputs if you have it in the field. So as you can see here, digital input on the left-hand side, and on both other stations on the right side, you have an output set all to the same address, and that's it. So very easy. That's what we call I/O mapping. That's the easiest way to build up a wireless communication and to share I/O data. No software is needed in this case. That's what the customer likes. Yesterday, I talked out to a refinery, and they like it very well. Yes. So that is an application here. That's a typical one in the wastewater treatment plant. So if your pump station, sometimes they are 700 meters or 1.7 kilometers away. So here you can build up a line structure, as you have seen in the video. So all the devices can act as repeaters, so we can increase the distances. And yeah, so that's something here, the very easiest way, if you have a pump station, to monitor the pump or control it, then it's possible with the I/O to I/O. On one hand, it's also very secure because no Ethernet port is on the device. So thinking about cybersecurity, that's also a very easy point. If you just transmit I/O data, it's secure at the end. Then the second option, I/O to Modbus RTU, what I mentioned. So it looks like this. So you have a Modbus PLC. So the customer, in some cases, when we talk about water, wastewater, they sometimes have the Siemens controller, of course, but here it could be also, of course, our PLC Next control as a Modbus master. So then the Radioline master device set up to 01 is directly connected to the controller. So then the Radioline device here acts as a Modbus slave. And in the field, you have Radioline remote stations, and you can connect here I/O data. So from a pipeline structure, then you can directly send these I/O data to the Radioline base, and this will be mapped directly into a Modbus map and transferred to the controller. So less wiring at the end for the customers, and very easy handling. And of course, you can also transmit several monitoring or diagnostic parameters. So that could be here. We had also some application in different cities to transmit it. Modbus RTU, so in a controller, you have a controller, wireless system, and in a field, You have a lot of Radioline systems and transmit the I/O data directly to the control room. Here one example. So we got also sometimes these questions. We have in this case also a description in the eShop. You can download some papers where we have described all these kind of solutions. When some customers, they have a tier portal from Siemens, and this one act as a Profinet master. Then with the help of our protocol converters, we have one from Modbus, RTU to Profinet. You can directly integrate the I/O data from the Radioline system over the protocol converter directly to a Siemens PLC, for example, to Profinet. At the end, you can use it also with our PLC Next control, which acts as a Profinet master. The third option, serial to serial. So here what I mentioned is the Radioline system. So the head station, the wireless module, has directly on the terminal blocks here below an RS-232 and RS-485 interface. You can connect, in this case, when we talk about Modbus or Profibus, it's an RS-485. You can connect directly two wires to the Radioline. And in this case, you need the free PSI-conf software to set up the serial parameters in the device. But in this case, we just build up a wireless communication or wireless cable from one side to the other side. And then we can transmit the data from one controller to the other ones. And yeah, that's very easy. So with Modbus, it's very easy. Later you will see we have also different kind of Radioline devices for different frequencies, 868, 900 and 2.4 gigahertz. Profibus, there are some limitation because we do a transparent transmission of the data, but we get a latency time over the air, so around 50 milliseconds, and therefore the speed must be reduced in the Profibus. And of course, it's something only for the 2.4 gigahertz radio. But here we have also a white paper for this stuff. During this session, we don't want to jump too deep in all this stuff. But here, if you have questions, please let us know. Serial to serial, of course, the energy meter. So just in the energy market, we have it also several times included. The EM Pro from Interface. So you can directly connect to a Radioline system, and then you can transmit the data to a controller on the master station. So just as easy as laying a cable, you can directly install the Radioline wireless system. And the fourth option, it's what I mentioned, I/O and Modbus RTU in parallel. So what's behind this? It's more or less the same as before. So we have a Modbus master. This one is connected to our Radioline master module. Here we can connect also I/O extension modules. Also in the field, as I told you, you can collect I/Os input and outputs, transmit them directly to the Modbus controller. But in this mode, you can also in parallel install a serial device, as you can see here on this picture. So here the I/O card connected, and of course here the EM Pro directly connected to the RS-485. So sometimes it happens that we have these kind of requirements from our customers. Yeah, or here in this example, we have a card reader. Also for this door gate, we connected directly to the I/Os, and the card reader over Modbus is connected directly to the radio, and then we transmit it to our PLC Next control. So in this option, it's possible. So the customer do not need a second system in parallel. So at the end, he saves a lot of money and installation costs. Yeah. So that was a short overview about all these four options we have with Radioline in the case of wireless. But yeah, the system, as I mentioned, in one point it's very easy, but sometimes the customers they need more informations. Therefore, I mentioned it also in the explanation before. So we have a PSI-Conf software. It's here on the left-hand side. It's a free software. All customers can download it in our eShop. And with the help of this software, you can do some diagnostic, but on the other hand, also configuration stuff. Some customers, they need it, especially when you will do a serial-to-serial communication. Then, of course, you need this software. Also with the parallel mode and so on. And yeah, therefore the CConf software is very helpful. But here we have also some videos on our YouTube channel, for example, or if you have other questions, let us know. On the right-hand side, you can see these configuration sticks. So that's also some very special things. So to make a network very secure, we have some conf sticks. But here, I don't want to jump too deep because it's too much for this kind of training. But these are very important sticks, unique sticks. You need only one stick for each network to make it 100% secure. No other Radioline systems can interact them. And yeah, they just let you know if you sell a Radioline system, and then you can directly offer also a configuration stick. Or the Radline cable, with the help of the software, you can do also some changes. Yeah, so what I mentioned before, so we talked about Radioline. Radioline is a wireless system. So that was a basic idea many, many years ago. But yeah, after a while, we worked through, or we are in contact with so many customers. And some guys told us, yeah, of course, we have a pump station far away. We have 3 or 4 of these pump stations there installed. There's no communication, no cables are in the ground. But we have another station, there's a cable. Can we use it also and integrate it directly in the system? And in this way, we got the idea to build a Radioline head station without the antenna. So it's an RS485 module. So therefore, the easiest way, we have the chance to share I/O data over a cable, over a 2-wire cable. So here you can directly connect to the head station the I/O system, the I/O extension modules. That means without a controller, you can connect here on digital input and digital output, and you can share the data, so like a multiplexer. And also, these devices, they have an Exxon approval. So if you have a special requirement in the process industry, for example, without programming, you can share data very, very easily. So that's also an idea to jump in this kind of applications. Here, multi-point multiplexer. As I mentioned, we can also not do a point-to-point. So we can build up a line structure of this. So you can install several devices in the field with the help of the cable. Also, one Radioline station can only act as the Modbus slave, like a bus coupler from Axioline, more or less. But this device, so this bus coupler or this step station, I/O station, has also X approvals for the Exxon 2 and is also very flexible. And at least you can mix it up, of course. So you have a wireless system, and then you can expand it with a cable. Yeah, and then you can share data over the air, over the cable, so very easily. Yeah, that's why we told you very flexible Radioline system with many options. But I think there are so many explanations. I showed you now a lot of options, and that's very, very hard now, I think, for you to follow us. But yeah, we just want to jump more about the products. We want to explain you something about that. And here in this point, I will hand over to Benjamin.
Yeah, thanks, Jörg. Okay, I will tell you something about the different head stations and I/O modules and what features are behind the articles. So in general, all these devices which we have an X-zone approval that can be used in the process industry. One of the unique features is the easy startup with the thumbwheel, which Jörg has already explained, and the I/O mapping. This is something what was a really innovation, more than 10 years ago. And then we have add more and more functionality into this product. Together with the I/O connection or easy I/O sharing, the serial cable replacement, the integration of the possibility to integrate Modbus devices and integrate the I/O signals from the field into a Modbus PLC, or also the extension via RS485 to do the parallel mode or to communicate via cable to a head station. The product family can be used worldwide. We use it with different frequency bands, 2.4 gigahertz, 868, 900 megahertz head stations. It's possible to adjust baud rates to increase the distance with lower baud rates and higher baud rates to speed up the communication, for example. And it's possible to achieve ranges up to 32 kilometers with line of sight with these 900 megahertz radios, for example. The system is flexible and it can be expanded with up to 250 radios per network and up to 32 I/O modules per station. This is a limitation per radio head station. We have different I/O modules, digital, analog, 4-channel, 8-channel relay or transistor outputs, and also PT100 signals, for example. And the system is hot-swappable. That means during operation you can add I/O cards. And all these devices have galvanic channel-to-channel isolation. So these are the different radio head stations. You can see on the left side the worldwide version, the 2.4 gigahertz frequency band is used worldwide. Also wireless LAN devices, for example, use it, or Bluetooth. And with this radio head stations, we have the most approvals on it because of worldwide use. And it's possible to achieve 5 kilometers with line of sight between two devices. You can extend the network with repeaters and so on and build up a big mesh network. If we talk about transmission time, it depends also from the different modes. But you can, if you use an I/O mode, for example, to transmit input to output, around about 200 milliseconds is the latency over the air. Then we have a head station. This is usable for the Japanese market, where you can install this device. Then we have radios for 900 megahertz frequency band for America and Australia. Different articles. And with these devices, these are much more powerful. That means you have a transmission power of 1 watt. And with these, you can achieve up to 32 kilometers in these frequency bands. Then we have a Europe version in the 868 megahertz band. This is the same frequency band like, for example, LoRaWAN devices are working. And with these devices, you can achieve up to 20 kilometers. And because of the frequency band and the higher distance and the regulation in the frequency band, that means it's not allowed to transmit 100%. It's, for example, allowed to transmit 10% of the time, and stop communication for 90% of the time. So in this case, we have a higher latency than in these 2.4 or 900 megahertz bands, up to 2 seconds if you transmit one input to an output module, for example. And the last head station for wired communication, up to 1.2 kilometers over 2-wire cable. So a huge number of I/O modules, 4-channel input, digital output with relays, then 8-channel input, 8-channel, 4-channel Namur input module, 8-channel output module for transistor outputs. Then we have a 4-channel analog module with 4 to 20 milliamp for 4 to 20 milliamp signals, and an output module where you can choose between a voltage or current output. And also a combined module with digital and analog in and outputs, and the PT100 module. So this is a huge portfolio of I/O modules which can be connected via a bus feed to the head station. Then there are some products which can be used directly outdoors. It's an IP66 or housing. In this device is integrated a 900 megahertz radio together with I/O module, which can be used outdoors directly at a pump station or whatever, or in the field to measure temperature or liquid level. And on the right side, we have a configurable box where you can choose head station and up to 3 I/O modules. It's a configurable article which can be configured via eShop, and you can select the modules which you need. There are integrated power supplies, surge protection, and everything what you need to place it directly outdoors. So yeah, different accessories. Omnidirectional antenna, which need to be used, for example, indoors, where you can have reflections, or also outdoors for repeater stations where the other radios are placed around a repeater, or directional antenna to achieve big distance, point-to-point communication, for example. Different cables and surge protection or a barrier to use antennas in X areas. Yeah, this is just a picture to get an idea how to install it in X areas. You have an IP54 housing with the radio station and the I/O modules. Place the antenna connector, and with this antenna barrier, you have the possibility to integrate antennas in zone 0 up to zone 20 for dust areas, for example. Okay,
Yeah,
then we have a short survey again.
Yes, so short survey. So we have explained you something, and yeah, I will start the survey. I think it's very easy. So do you see potential uses for Radioline in your country, just in general? So what do you think about that? Do you see some potential when you see especially for the guys, they not heard about all this stuff. Do you see there's a potential or not? Yeah, as I can see. Yeah. 30, about 40, 97% says yes, 3% say no. Okay. So most of you say, okay, we can see a potential. 2% say no. So one guy changed his answer. Okay. So Benjamin, I think, yeah, we're on the right track. So our guys, they say they have some potentials there. Okay. Please continue.
Yeah, okay, Essential Wireless. This is a special module which we have developed for price-sensitive markets like photovoltaic industry, for example. The module has another color. It's a black colored housing in addition to the Essential family of Phoenix products. And this device is not part of the Radioline family. It cannot be expanded with I/O modules or whatever. It just has an RS485 interface, limited functionality in case of diagnostic and so on, to reduce the price for this device. But it includes also the trusted wireless technology. That means the benefits of mesh network, range, and so on. We have set up this device several years ago because we got requests from the photovoltaic industry. That means customers want to network their string combiner boxes to the central inverter stations. So, and all these devices which are installed there have Modbus RTU interfaces, also because of less prices. And therefore, we offered the solution Essential Wireless many years ago. And these are the use cases where you can use it, for example. It's not necessary to offer it just for the photovoltaic industry, but it is one of these where we have problems with high prices of electronic products. So very simple use case. Typically, you have one control center, install an Omni antenna on the highest point, then place the master radio, and in the field you have the different string combiner boxes with a slave radio, and you can transmit up to 500 meter if you place the antenna not very high in the height of the solar modules, for example. So, and then you can network a huge photovoltaic park. So, yeah, the device need to be configured with a PSI-conf, just RS485 interface, can be used worldwide, use 2.4 gigahertz band, and has a range of up to 500 meter with line of sight in point-to-point connection. The most benefit of this in the photovoltaic industry is that you have an interference-free communication, and it's immune to electromagnetic interference if you compare it with cable laying, for example.